Alright, you guys, today in class we talked about conditional probability, and remember, that is the probability of event B occurring given that event A is also occurring. So remember, we had our formula here, the probability, the intersection of divided by the probability of event A. So if you look at a Venn diagram, again, in theory, it's going to look like that. So what we're doing is we're saying, okay, well, forget about that. All right. Given that event A, the yellow ring, is occurring, what is the probability that event B also occurs? So it's no longer out of the whole 100%, it's out of whatever event A is. All right. So in problem number 1 here. All right. So the probability of a house having a VCR, given that it has a TV. Again, we're no longer out of 100%. It's out of the 88% that actually have a VCR. Well, 51%. Okay? So that is your intersection. So if we're actually going to draw a picture here, we'd have the TV side over here. That's 88%. And then we have the VCR side, which we don't know, but we know that the intersection is 51%. Okay? Which then also means is that the TV only side is actually only 37%. Okay? Anyway, when you actually do it out, you get 51 out of 88, or 0.51 out of 0.88, which is equal to 0.5795. So a little under 58%. All right? Same thing over here. If 56% of all children get an allowance, 41% get an allowance and do household. So again, the probability of event A occurring is 0.56. The probability of A intersect B is 41%. And the probability of event B, given that event A is occurring, is just 0.41 over 0.56, and I forgot what that was, but it's a little over 73%. All right, we're making progress. All right, at the middle school, 18% of students play football, 32% play basketball. Scratch that. 18% plays football and basketball, 32% play football. What is the probability that a student plays basketball given that they play football? Okay? Now, in class, we talked about this. Okay? What if you did this backwards? You said, oh, okay, you kind of got robotic and just took the second percentage divided by the first one. Okay? You get 1.7 repeating. Well, what do we know? Well, we know that the probability of anything occurring has to be between 0 and 1. All right? I mean, in theory, we also know that the sum of all probabilities is equal to 1, but that doesn't apply here. All right? So, whoops, let's do this right now. It's the 0.18 out of 0.32, which is 56.25%. I forgot the 6. And we are good there. Let's change to a nice color for this one. Again, I'm not even going to read it. I am not even going to write notation. I am just going to do what you know that we should be doing and get 0.8125. So again, 81.25%. All right. I zipped through those, and I'm going to take a little more time looking at the little mixed review problems down here at the bottom. Okay? Because, you know, if you're going to play cards, you need to be informed. All right, one card is drawn. What is the probability that the card is either red or an ace? And, all right, so the probability that it is an ace, as you all know, is 4 out of 52. The probability that it's red, well, 26 cards out of a deck are red. But what we need to remember is that there are a couple of cards, 2 of them to be exact, that are red aces. So 2 out of those 52. So now when we actually go to use the formula, the probability of an ace or a red card. All right, remember, it's the 4 aces plus the 26 red cards minus the 2 we're counting twice. All right, and when you actually do that out, you get 28 out of 52. Okay, and that does reduce. That reduces to 7/13. Next one. 2 cards are drawn without replacement. So that means we are going to have 1 card and then another card, which means hopefully in your head you're thinking, all right, multiplication rule. All right, so again, 4 out of 52, that's the first ace. And since you are holding an ace, that means 3 aces are remaining from the 51 cards. And now if you actually do it out, math fracket, you get 1 over 221. Few more. All right, 5 cards are dealt to you without replacement. What is the probability that you get 5 hearts in a row? All right, well, the probability of the first one is a heart, 13 out of 52. You are holding a heart, which means the probability of the next one is 12 out of 51. And the third one, 11 out of 50. And the fourth one, 10 out of 49. And the fifth one, 9 out of 48. All right, and notice here, you see that I did the calculation, and we do get scientific notation. So we get 4.95 E negative 4. All right, so what that really means, the probability of 5 hearts dealt to you in succession is 0.000495, and if you want another number, it is 2. All right, so the probability you draw 1 card and look at it. I tell you that it is red. What is the probability that it is a heart? Okay, so the probability of a red card is 26 out of 52. The probability of getting a heart is 13 out of 52. All right, now the intersection, the probability of getting a red and a heart, well, that is also 13 out of 52. So, just in case you're wondering, the late bus is here. All right, now, so the probability of getting a heart, given that it is a red card, is the probability of the intersection, 13 out of 52, over the probability that it is red. Again, given that it is red, meaning 26. So there's 26 out of 52 that way. And hopefully you know a little bit about math. And when you have these complex fractions, common denominators cancel out. We get 13 over 26, which is 1/2. And let's think about it logically. Yes, half of the red cards are hearts. All right, so we've used these words, independent events and disjoint events. Okay? Now, the independent events is when you have multiple trials of some kind of, probability experiment, and that the outcome of one event does not affect the probability of another. Okay? Whereas disjoint events is when there's going to be one probability experiment and that there's just no overlap of the Venn diagram. No overlap. I like that. No overlap. Okay? So that means 2 events that cannot occur at the same time. That was kind of like the M&Ms. You can't be red and green. All right? Well, I hope this little video helped out, and I hope that you are having a wonderful day. Peace out.